Now, organic chemistry, first of all, what are organic compounds? Okay, all compounds that contain carbon, hydrogen, and some other additional elements like nitrogen, sulfur, phosphorus will be present in them. Here in organic compounds, we are not going to include carbonates and carbon dioxide. So these both classes of compounds will not be included in organic compounds. So basically they will be carbon compounds. What is the important property because of which organic compounds can form almost unlimited number of compounds? Okay, the special property of carbon is possessed. This carbon, its electronic configuration of carbon is 2,4. It is going to share 4 of its electrons and it is going to form 4 bonds. Now this carbon can link itself with other carbon atom up to thousands of carbon atoms. Of course, the valency of carbon is always 4, so it will always have 4 bonds. So in this way, it can form chains of thousands of carbon atoms. This special property that is possessed by carbon is known as catenation. So catenation is a property in which carbon is bonding with another carbon atom, can form unlimited length of chain. So the property of direct bonding between atoms of the same element is known as catenation. This is about the property of catenation. We come to the next part, that is the simplest organic compounds. These are going to be hydrocarbons. So hydrocarbons are simple organic compounds that will contain carbon and hydrogen only. Of these, alkanes will be the simplest of all the hydrocarbons. They will be containing carbon and hydrogen, carbon that is bonded with hydrogen atom, or if it is undergoing catenation, there will be more number of carbon atoms and it's going to form carbon chain. There is a general formula that relates the relationship between carbon and hydrogen atom. This general formula is CnH2n plus 2. It means if n gives you the number of carbon atoms, the number of hydrogen atoms will be given by 2n plus 2. So you can start with n is equal to 1. You can substitute over here 2 into 1 plus 2. So number of hydrogen atoms is going to become 4. The formula of this compound is going to be CH4. This is the simplest of all the organic compounds, which is methane. You can also look over here, alkane. The name is ending with ANE. This name methane is also ending with ANE. Suppose if I'm taking n is equal to 2, that is the next of alkane. Okay, this is going to have the number of carbon atom is 2, number of hydrogen atoms you can calculate, so it's going to be 6. It's going to become C2H6. This is the next of the compounds that is of alkanes. Its name is ethane. Okay, so this is also ending with a ANE. N is equal to 3 you can calculate this. This is going to become C3H8. This name of the compound is going to be propane. And then we can take N is equal to 4. This is going to become C4H10. If I substitute in this formula, this is going to be butane. Okay, similarly, you can go up till chains of thousands of carbon atoms. These are all the formulae that we have found out. These are known as molecular formulae. We are going to represent this in the form of bonded structures. These all will be known as the structural formulae. Before we go into the structural formulae, I want you to take down all of these things, whatever is there on screen. If you have any questions, you can ask me. So these are the structural formulae. For methane CH4, you are going to show carbon with each and every individual bond that with other atoms that carbon is bonded to. Okay, so this is the structure of ethane, C2H6. This is the structure of propane, that is C3H8. and this is the structure of butane, that is C4H10. Now, if I'm not showing all of these bonds, only either I can show it between the two carbon atoms, or even without that also. You can see over here, carbon is bonded with 4 hydrogen atoms, so the content structure will be CH4 directly like this. The content structure for ethane, okay, you can see this carbon atom is bonded with 3 hydrogen atoms, so that is shown over here, CH3. And again over here, this is again bonded as CH3. Same way over here, this is CH3. This middle portion over here, this is CH2, and this is CH3. In the same way, we have shown the structure of butane, that these all structures that I have drawn, shown in green, these are known as condensed structures. When we are asked to draw the structural formula, we are supposed to show each and every individual bond of carbon atom. When we are asked to do the condensed structure, we have to show it like this. Just take down all of these and then we'll move on to the next part. See, these are the structures that we have already drawn. Now, if we see here, this is methane. Okay, now if this part, I'm going on to the next hydrocarbon. Okay, that is here, it's bonded to the next carbon atom. Each one of these carbon atoms is going to have 4 bonds, and hydrogen is having a single bond. Okay, if this structure would not have been there, this will become methane. It means on addition of this much part, I am getting the next hydrocarbon or next series of alkane. Same way over here, I can do with that. Here C2H6 is there, in between another CH2 is added, and then another CH2 is added. So here this is going to form a series of compounds which is going to be known as homologous series. So this is going to be our next definition, that is homologous series. So how we are going to get this homologous series? We just are going to increase the carbon chain length by adding one CH2 group. You can see over here CH4 is there. Here when CH2 is added, so here plus CH2 is there, is going to give us C2H6. To this also, if I add CH2, I'm going to get C3H8. So every time in the middle, 1111 CH2 is going to get added. So this series of compounds that we are going to obtain will be homologous series, and this particular series which is there is going to be homologous series of alkanes only. Same way when we are going to have other kind of compounds, either hydrocarbons or other elements which will be containing oxygen or chlorine and so on. In that, each one of these is also going to form their own homologous series. So every particular functional group that is there, that's the definition, next definition that also I'm going to give you. Okay, so every particular functional group is going to have its own homologous series. So we'll just write down the definition of homologous series and some characteristics of homologous series that are there. They are also important. Okay, so this is the definition of homologous series: is a series of organic compounds that have the same functional group and the next member differ by CH2, as I have explained earlier. Just take down this definition and then I'll give you the definition of functional group. Okay, so these are the characteristics of homologous series. The next member will differ by CH2 group, and when you go to the move to the next member, the RMM, that is molecular mass, increases by 14. This obviously you can see carbon, the atomic mass is 12 and plus 2 hydrogens. So the next member will have molecular mass greater by 14. Then as the carbon chain length increases, it means more and more number of carbon atoms are getting added. The melting point and boiling point of the next members will keep on increasing. And generally this happens as the carbon chain length increases, the reactivity decreases. And because they have the same functional group, their chemical properties will be similar. So this point is going to be very, very important. So these were the characteristics of homologous series. Now here we have considered the first 4 examples of alkanes before. Each one of these hydrogen atoms is replaced by an OH group. So at all places, I've removed one hydrogen atom, and that has been replaced with this OH group. This OH group in organic chemistry, we will call it alcohol. Okay, so this is the class of compounds that is known as alcohols when OH is present. Remember, in inorganic chemistry, when OH is present, we call it hydroxides. For example, NaOH is sodium hydroxide, KOH is potassium hydroxide. So this class of compounds which contain OH group is known as alcohols. Now, because of the presence of this OH group, this compound CH3OH will have some similarity with the compound, the next compound that is there, that is going to be C3H7OH. We have already considered the name before in IUPAC nomenclature. Okay, so that part in the end we are going to see it again. So there will be similarities in properties of this, all of these compounds because of the presence of this OH, and this particular group of atoms O and H is going to be known as alcohol. Here, because it is going to give characteristic property to a compound, this OH group is known as a functional group, and the name of this functional group is going to be alcohol. Similarly, I'm going to consider another example over here. Okay, suppose instead of all of these 4 hydrogen atoms, I have replaced all of these with chlorine atoms. Now, because of this presence of this chlorine atom, all of these compounds will have some similar chemical properties. So, functional group is going to characterize or give special characteristic to a particular class of, or the series of these compounds. And of course, we know that this is homologous series because each one of these is going to differ by CH2 group. Same way, I'm going to consider one more example over here. This is another series of compounds that is containing COOH. This is nothing but carboxylic acids. So because of the presence of the COOH group, all of these will be having similarities in properties. So the name of the functional group over here is carboxylic acid, which is COOH. The structure of these carboxylic acids, COOH, if I'm going to represent, it's going to be like this. You should see that each carbon atom is always forming 4 bonds, and because the valency of oxygen is 2, it is always going to have 2 bonds. So we are going to write down the definition of functional group over here. This is an atom, as we have seen in case of Cl. Okay, so this is an atom or group of atoms that gives characteristic properties of compounds in a homologous series. These are the 3 homologous series examples that I have considered. We'll also write down the names of these compounds here. Okay, because here alcohol is there, so OL, it is ending with OL. This is containing 1 carbon atom, so it is going to be methane. I remove that E from here and I have put OL over here. So this is going to become methanol. Similarly, this is going to become ethanol. Propane is there, so this is going to become propanol. And this is butane, so this is going to become butanol. We have also considered here the position of OH group when we had taken the topic of IUPAC nomenclature. You have to give which position of the carbon atom this OH group is attached. Similarly here, in these next examples that we have taken, okay, we can give these names. Because here chlorine is present, this will be named as chloromethane. This is going to be chloroethane. This will be chloropropane. And this is going to be chlorobutane. Here also you can give numbering to the chlorine atom. The last of these series that we had considered, this is carboxylic acid. Here 2 carbon atoms are there. So this is going to be named as ethanoic acid because it is carboxylic acid. Okay, so its end name is going to be oic acid. So this is ethane, and it's ending with oic acid. Here 3 carbon atoms are there, so the name of this compound is going to be propanoic acid. Here there are 4 carbon atoms. This is going to be butanoic acid. Here there are 5 carbon atoms. This is going to be pentanoic acid. If there is only 1 carbon atom over here, then only COOH, this group will be there. So this is your carboxylic acid functional group, COOH, and that is attached to 1 hydrogen atom. So the name of this compound, because here there is only 1 carbon atom, this is going to become methanoic acid. So this was about the definition of the functional group. Okay, we will write down this definition of functional group, and then we will take down these examples. What is your question?
Is the alcohol a functional group or the OH is a functional group?
See, the group of atoms, atom or group of atoms will give you a special characteristic property. The name of that functional group over here is alcohol.
And the property is OH.
These are the group of atoms, oxygen and hydrogen attached together here. O is there, O attached to H, and that is attached to the carbon chain. So this OH group which is there, this is the group of atoms that is going to give you the special characteristic property. And the name of this OH functional group is known as alcohol.
Okay, got it.
So the next part is esters and esterification. The chemical reaction takes place between an alcohol and a carboxylic acid to produce a compound called esters. There is a separate link for esterification reaction which we will be going through just now. See, the question that you have asked me, what is the difference between alkane, alkyl,
Sir,
and
alkyl
alkene?
is not in a syllabus, huh?
It is. Without that, no organic chemistry. Now, alkane, I'm considering the example of C2H6. Okay, I'm drawing the structural formula over here. This is the expanded structural formula of C2H6. This is ethane. If in case if I am going to remove this hydrogen from here, which is going, this bond is going to get attached with some other group or carbon atom. This group which is there, okay, from this E and E, I'm going to remove this E. This part is going to be known as, this E and E will be removed, this part will be known as ethyl. And then from the same part, okay, from this part, suppose if I'm going to remove these hydrogen atoms and these both bonds which are there, they join together and we are making a double bond out of it. I've removed. So here also you can see the carbon atom, each carbon atom is having 4 bonds only. This is going to be here, double bond is present. So this ethane, this ANE is going to become ENE. So this is going to be ethene, which is going to be an alkene. Alkenes are double bonded compounds. They are unsaturated hydrocarbons. It means here, apart from single bonds, either a double bond or even a triple bond may be present. These are known as unsaturated hydrocarbons. While alkanes will be containing only single bonds, they will be known as saturated hydrocarbons. So this is the difference between what is an alkane, what is an alkyl, and what is alkene. Okay, you can just take that down and then we'll go to that part of the structural formula Okay, the expanded formula, and then here you have to mark ester linkage in this group. So first you will take this down, and then of course we are also going to take one more example which you are going to solve on your own.